Welcome back. This is 9.2 homework part 2, and at this point perhaps you've seen 9.1 part 1. Maybe you're looking for just a specific problem. Fast forward. But if you have not seen the 9.2 notes, that is an absolute must. Otherwise there's going to be things that I assume you know as I go through this that you actually do not know. Therefore, find the standard form of the equation of the ellipse with the given characteristics. Now, this is an x squared because it's wider than it is tall. So this is going to fit the model x minus h squared on a squared plus y minus k squared on b squared equals 1. There's 5 things we need to know to get an equation of a line. We need to know h. We need to know k, and usually those come as a pair. That's the ordered pair of the center. We need to know a, half the length of the major axis. We need to know b, and we need to know, is it tall and skinny or is it short and wide? When they give us this diagram, they pretty much give us everything we need right here. So this is a wide one, so it's an x. My center is right 2 down 1, and it's an x dominant, so that is, it's wide. It is x minus 2 squared on plus y minus negative 1, y plus 1 squared. There's h, there's k. A is the distance right here, or right here. A is 2, so this is on 2 squared 4. B is this distance. The up down is underneath the y. Up 1 down 1, 1 squared. And we've got it. So pretty nice when we've got a diagram. So my point being, maybe we should get diagrams on these, unless you're really a good abstract mathematician. A lot of people will benefit from diagrams, as I do. So here we've got vertices at 0, 2, 8, 2, and I got to tell you, one of the most common mistakes is we're so ellipse oriented now that we make a mistake and put this at 2, 0, 2, 8. Let's make sure we get this thing plotted correctly. It all depends on that. So 0, 2, 8, 2, maybe something like that. And those are the vertices. So the ellipse looks something like this. And right now, I know this fits the model. X minus h squared on a squared, because it's wide. Those are the vertices. Plus y minus k squared on b squared equals 1. And you might not write that down every single time, but I think it's good as we're learning it. So what do I have? HK, the center, is, I like to believe, clearly at 4, 2. Over 4 up 2, halfway between 0, 2, and 8, 2. So I've got H, I've got K. A is that distance 4, or that distance 4. So far I've got X minus the MyVox 4, most interesting value of X squared, on A 4 squared, plus, let's see, I've got y minus 2, the MyVoy, most interesting value of y squared, on how far up does it go? Don't have that yet. But all I've done is been given the vertices, and take a look, I'm given the vertices. I learn h, I learn k, I learn a, I learn 3 of the 4 things I need to put in here. I also learn that this is wide. It's a wide one. So really 4 of the 5 things that we really need to know just by plotting the vertices. So then the next piece of information, I get the minor axis. That's the entire minor axis, has a length of 2, which means it goes from center up 1 down 1, and therefore B is 1. And we got it. Okay. Here we get the foci, which aren't, it's not my favorite to get. I'd rather get vertices. I'd even rather get the minor vertices, but it is what it is. The foci are the origin and 0 up 8. So I'm going to put that over here. So we've got, we'll just call this up 8 and down, and 0, 0, 0, 0, 8. So those are our foci, and what I know is the curve wraps around the foci, and that is true whether it's parabolas, ellipses, hyperbolas, as you're about to see. The curves wrap around the foci. So somewhere up here we have vertices. They could be way up, they could be really close. That information we don't know yet. But I do know that my center halfway between these is at 0, 4. I also know it's tall. So this is an x minus 0 squared on plus y minus 4 squared on equals 1. And I'm ready for the next piece of information. The next piece of information is the major axis is length 36. That means from the center 0, 0, I go up 18, down 18. I wasn't even close with where these curves are. Up 18, from here to be up 22, down to negative 14. I'm not going to draw it. What that tells me is that the distance to the vertex from the center is 18. Therefore, A is 18, and it's an up-down. Y is up-down. We're on 18 squared here. I need to know how far over it is. I need to know what B is. Here's what I've got. A equals 18. B equals, I don't know. C, a second here. C is the distance to the foci. The distance to the foci from 0, 4 to 0, 8 or to 0, 0 is 4. And now I've got to go ahead and figure out B, but A, B, and C are in a Pythagorean relationship, and that relationship, A is the big one. So 18 squared equals B squared plus 4 squared. 18 squared is 324 minus 16. So I get 324 minus 16 is B squared. B squared is 308. So that is B squared. So I end up with 308 right here. So if you like, you want to clean that up a little bit, we get x squared on 308 plus y minus 4 squared on 324 equals 1. Okay, and this one, the center's at 3, 2, and then they say A is 3 times the length of C. All right, well, let's go with that. The center, kind of a weird one here. The center's at 3, 2. The foci are at 1, 2. And 5, 2. So those are the foci. So the curve wraps around it like this. Let's see. This is a wide one. So this could be x minus 3 squared on plus y minus 2 squared on equals 1. What do I know? A, don't know it yet. B, not sure of it, but C is the distance from the center to the focus. From 3, 2 to 1, 2, it's a step of 2 or a step of 2. Oh, and A, how convenient. A is 3 times C. A is 3 times 2. A is 6. So A, we move out 6 and 6 to get to our vertices. So that's right and left 6, 6 squared, 36. And A squared equals B squared plus C squared. B squared is 32, which might be useful to know what B is, but I don't need it for this. 32. All right, and it boils down to this. Find the center, the vertices, the foci, the eccentricity, which we spoke about but haven't talked about in this assignment yet, of the ellipse, and sketch it. I may just sketch it and then find the other things. Let's see what we got here. Right and left 0. Right and left 0, so our center, might as well get it. 0, 0, right and left 0, up, down 0. We don't go to the right, we don't go to the left, so we start at 0, 0. So we've got, we're going to move up 8, down 8, right 3, left 3. So let's just do this. Up 8, down 8, right 3, left 3. Try to do a decent job with this, not great. So this would be 3, this is 8, negative 8, negative 3. So there's a decent graph of it. What else do we need here? Find the center, find the vertices. So the vertices are at 0, 8 and 0, negative 8. I'm going to reserve the right to maybe ask at some point, talk about the minor vertices, which would be plus or minus 3, 0. But when they're asking for the vertices, they're asking major axis. The foci, we need to know the foci. So once again, I've got A is 8, B is 3, C is, I don't know, but I do know that 64A equals 9, A squared equals B squared plus C squared. C is 55, C squared is 55, C is square root of 55. Therefore, the foci are not to the right or left at all, but they are up and down square root of 55. And finally, let's see, check them off. Center, vertices, foci, eccentricity. The eccentricity, let's call it E. The eccentricity is defined as C on A. It's really a measure of the roundness. I'll show you how kind of neat that is. So this is square root of 55 on 8. And if we understand this, which we should, C is always going to be less than A. The foci are always going to be inside the ends of the major axis. So C divided by A is always between 0 and 1. So 0 is less than C is less than 1. And this is kind of cool and makes it easy to remember. It's a measure of roundness. The closer C is to being 0, the more the ellipse looks like a 0. The closer C is to being 1, the more the ellipse looks like a 1 or a sideways 1. Okay, so kind of nice to know. A lot of times that's discussed when you're talking about like planets as they're rotating about the sun. All right, let's take, graphing this thing's a breeze. We've got a center of 4, 1. We've got from there 4, negative 1, excuse me. From there I'm going to go up, down 4 and right, left 5. So maybe something like it's down a little bit more than it is up. It's mostly to the right. Notice it's going to go to the right 4. It's going to start to the right 4, and it's only going right and left 4. So I'm going to do C down 1. I'll do this. So here we go. Center at 4, 1, 2, 4, 4, negative 1. And we're to the right and left 4 from there. So this would be 8, there's 0, this is negative 2 right here. And we are up and down 5 from there. So if this is, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We got something like this, which is pretty circular, so I'm going to make sure, okay, the major axis is here. There's our major axis because 5 is bigger than 4. Okay, so we've got center, we've got the graph already. I'm looking for the vertices. The vertices from 4, -1, we went up 5. Up 5 would get me to 4, 4. From 4, -1, we went down 5. That would get me to 4, -6. We need the foci. Well, for the foci, I need C. Can't spell foci without C. Let's use some space down here. I've got A squared 25 equals B squared 16 plus C squared. C squared is 9. C is 3. So we're up 3, down 3. Down 1, 2, 3. So the foci are still to the right 4, but from -1 we go up 3 to 2. We go down 3 to -4. So we've got the center, we got the vertices, the foci. The eccentricity is C, which is 3, on A, which is 5, 3/5. Okay. A little clumsy here. Right 5, up 1. And then we're only going up and down 1 and right and left. That's 3/2 squared. Right and left 3/2. So our center is at -5, 1. And from there we're barely moving. We're not moving much at all. Computer screen just froze out. Don't know if you guys noticed that or not, but I think it just timed out there. Hopefully, yep, looks like we're still in order. Okay, so if I'm going to sketch this thing, I'm left 5, I'm up 1, and I'm not moving very far from there, so I'm going to actually use tick marks of 1. So let's see. Left 1, 2, 3, 4, 5. Up 1. So these are true tick marks right here. Each one is a step of 1. From there, I'm going to go up and down 1. I'm going to go right and left 1 1/2, 3/2. Okay, it's a little eyeball looking thing. All right, so that tells me that the center, of course, is -5, 1. The vertices are 1 1/2 in from both sides. So that's 1, 2, 3 1/2. Vertices at -3 1/2 up 1, and 5, 6 1/2, -6 1/2 up 1. The foci, that might be a little bit ugly. Let's see. Foci, I know that A is 3/2, B I don't know, or no, B is 1, and C, and they live in Pythagorean, so 9/4 equals 1 plus C squared. C squared equals 9/4 minus 1/4, 5/4. C is plus or minus square root of 5 on 4. And now here's a sneaky thing. Plus or minus square root of 5, that's a little more than 2 divided by 4, a little more than 1/2. So I don't know, somewhere around in here and here. Now I need to come up with the ordered pairs for this and this. And this is big. You might want to watch this a couple times. I don't really, truthfully, I didn't get to this point by going to the left this far and up that far. I really went left 5 and then back to the right, square root of 5 on 4. So here's how I'm going to list that. The foci, I went left 5. Then I went back to the right, square root of, that's square root of 5 on 2, by the way, square root of 5 on 2. But good news, they're just up 1. And then to get to this point, I go left 5 and another square root of 5 on 2. So plus or minus square root of 5 on 2 gets me to the foci. And if C is square root of 5 on 2, then the eccentricity is C on A square root of 5 on 2 over 3 on 2. That's square root of 5 on 3. So you got a little bit of something going on that second page there. Stay tuned. Part 3 will be coming soon.